Assalamu alaikum. My name is Qasim Raza with my fellow CEP Gilani. We are here to present the task which is given to us by Dr. Zakai Imad, who is an associate professor in mining engineering department in UT Lahore. First of all, I would like to thank him that he has given us the opportunity to work in that project. Moving forward to the introduction of the project, the introduction is that we have an open pit mine, which is basically a copper mine that is located in Rakodik in the Balochistan. The whole rock mass consists of two major rocks, which are norite and granite. The other parameters like the condition of the joints, orientation of the joints, and infilling and the groundwater condition and the core run is given to us, which would play an important role to find the rock stability, which is basically the most important question which we are going to solve here. We will go towards that step by step. First of all, we will find RQD rock quality designation. It is very simple to calculate by using the core run data. We will use its formula and the core run data, and we can find it easily. After finding the RQD, we will go towards the rock mass classification. Rock mass classification is basically and the critical thing which we should know before the further investigation about any construction site, especially in mining field. There are quite a number of systems in the world right now, but for our convenience and the simplicity, we will use a rock mass rating RMR system. RMR is very easy and simple and convenient to use. After finding the RMR value comes in the range of the fair quality of the rock, which is quite good. After finding the RMR, we will go towards the rock mass properties. Properties are always the most important thing to know if you want to know about the mass. So to find the rock properties of the mass, we will use a rock lab or rock data software to find the rock mass properties like cohesion, friction, Young's modulus, and the properties like that. It would also give us a major and the minor principal stress working at the granite and norite. After finding the rock mass properties, we will go towards the in situ stresses. In situ stresses are the most important thing in the stress field, because if you want to work on any construction site, especially in the mining field, you should know about the in situ stresses. In situ stresses basically deals with the vertical and the horizontal stresses. These are very easy to use because the given data, because the required data to find the in situ stresses are given to us. After finding the in situ stresses, we will go towards the geotechnical parameters and additional parameters that can affect the rock stability. There are quite a number of parameters like the environmental impact, the slope, deep bench width, bench height, friction angle, and other parameters. There are same parameters that can affect the rock stability. From now on, Hasib Lani will continue. Thank you so much.
The basic purpose of the problem is to design of slope which is suitable. Basically, there are three types of angle in slope. One is the frictional angle of the material. Second one is the failure plane angle, the angle at which the failure will occur. And third one is the slope angle. Slope angle, we cannot change the frictional angle, but we can interpret slope angle and failure angle so that we can remove failure. The frictional angle is given, and for the computation of failure plane, we use the data of dip and dip direction of faults. We use the data of dip and dip direction of faults to identify the failure planes. After plotting failure planes of tyrannite, we have drawn slope planes such that, keeping in view, there is no planar or other failures. From here we have calculated our slope angle. To have the quantitative measurement of stability of slope, we have put this slope angle in SMR and find the SMR reading of slope. SMR gives us the quantitative measurement of stability of slope. For verification of rock stability, we have used Face 2D to verify our slope angle. We have found that 30-degree slope angle is optimum for stable slope design of an open pit mine. This approach is applied throughout the 360-degree angles of slope, and the optimum slope angle is calculated.